Welcome to Unit 1, Lesson 12. This is Part 2 of our notes. This is the second video. If you missed Part 1, go back and watch Part 1 of Unit 1, Lesson 12. But we're just going to continue right where we left off with writing the equation of a circle. Doesn't get much easier than this, right? We should remember that the equation of the circle is x minus h squared plus y minus k squared equals whatever my radius is squared. We should also remember that the center of the circle is my h and k. Now, when our numbers go into our equation, we really flip the sign, meaning we'll have h plus 3, even though it's a negative 3. How come? Because in all reality, I'm subtracting what h is. X minus a negative 3, okay? When I do that, I get a positive 3, okay? But sometimes it's just easier for people to remember. Just flip the sign when you put it in. And that's what I'm going to do here. So I have this quantity squared plus y. Okay, I'm going to flip the sign and make it plus 2 squared equals my radius squared. If my radius is 7, my radius squared is 7 squared, which is 49. And like I said, it doesn't get much easier than that. Love it when I ask us problems like that. Love it, love it, love it. On to number 2. Write the equation of a circle whose diameter has the endpoints, okay, 4, 1, and 6, negative 6, 7, I'm sorry. So 4, negative 1, and negative 6, 7. Okay, what we need to know here is this right here, the diameter, okay? So let's actually plot these points. 4, 1, 1, 2, 3. And I keep on saying 4, 1, but it's 4, negative 1 right here. All right? And we need to plot the point negative 6, 7. So I go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and then I go up 7. 1, 2, 3, 4, 5, 6, 7. So I am all the way up here. All right, that's negative 6, 7. And we had our point 4, negative 1 down here. So for the sake of ease, I'm just going to erase these things right here. And all I know is that that line that I make here, that's my diameter. It's not my radius. It's my diameter. That means that cuts my circle in half. My circle touches both those points. What do I need to come up with my equation of a circle? I need x minus h squared plus y minus k squared equals my radius squared. All right? My radius is half of my diameter. So I need to find the midpoint. Not only do I need to find the midpoint to get my radius, the midpoint of the diameter is going to be the center of my circle. The center of my circle is h and k. So I really need to find that midpoint right now. You can eyeball it. You know, maybe I can find it. It looks like maybe it should be right here. But let's check it out. Okay. How do we find the midpoint of any line? Okay, this is midpoint, MDPT. I shouldn't abbreviate that because I'm really just missing one letter, the I. I just like to abbreviate everything. Midpoint. Okay? So what I do is I take my x values, I add them together, and I divide by 2. So I really just find the average. Okay? So I have an x that is negative 6 plus an x that is 4, and I divide that by 2. That's going to be the x value of my midpoint. And I do the same thing for the y values, meaning I take my 7, which is one of my y values, I add that to -1, and I divide that by 2. Okay? And that's how I find the midpoint. So that's -2 over 2, which ends up being -1. This is 6 over 2, which ends up being 3. That's my midpoint. -1, 1, 2, 3. Look at us. Look how good we are. That is my midpoint. Okay? Not only is that my midpoint, it's the center of my circle, and it is now my h and my k. So I have my h and I have my k. The only thing I need now is my radius. The radius is the distance. Okay, let's go to the green. The distance from the center of the circle to the outside edge. So if I could find that distance, all right, I could find my radius. And then whatever that is, I square it, right? So there's a distance formula, and that's nice and neat. But what I like to do, especially if I have two nice points like this, and it's on a graph, and everybody seems to like visual things nowadays, I'm going to make a little triangle here. And I'm just going to use the Pythagorean Theorem. Okay, if you notice, the green side, which is my radius, is the hypotenuse of my triangle, and it's a 90-degree triangle right here. This side on the left is 4 blocks tall. Okay, the side on the bottom is 1, 2, 3, 4, 5 blocks wide. Okay, and this just represents 90 degrees. So how do I find my hypotenuse? A squared plus b squared is c squared. And if it doesn't turn out to be a nice whole number, don't worry. Let me explain. All right, so my radius, that's pretty much going to be the c value in a squared plus b squared equals c squared. Now, here's my c value, or my radius. All right, so I have 4 squared plus 5 squared equals c squared. All right, well, that's 16 plus 25 equals c squared. That means 41 equals c squared. Remember, c is the same thing as the radius, isn't it? So then basically, I can say 41 is my radius squared. There's my radius squared. That goes in for this. All right? And I also have my h and my k, which will go in here. That's these values. So let's put those in the equation right now. So the first thing I want to do is I'm going to rewrite my equation and just input these numbers. We have x minus h squared plus y minus k squared equals my radius squared. X, let's not forget we're flipping this sign, right? That's going to be plus 1 squared plus y, flipping the sign, minus 3 squared equals my radius squared. Look at us go. That's a little bit of work. I would expect this on a geometry final. I haven't seen an Algebra 2 final that had to use the midpoint formula. Okay, sometimes you got to use the Pythagorean theorem, but it's rare. This is kind of more of a geometry problem. Some of the more common problems you'll see in the final would be completing the square to come up with the equation of a circle, like having to complete the square twice. We did that in part 1 of lesson 12. Or just basically coming up with the equation of a circle where they give you the center and whatnot. Okay? And on to the next one. Now we're just back to straight out algebra. This is where people feel the most comfortable, and that's fine. Okay? These are common problems. Solve the following system algebraically. It says and graphically, but let's just solve this algebraically for now. We won't worry about graphically for the moment. Okay? So, I'm looking at the problem they gave us. And why is this in the circles lesson? Because we have a linear equation, which is a line, and we have a circular equation, which, again, that's the equation of a circle. Okay, so we're going to solve these, and we're going to solve these by substitution. What do I mean by substitution? Well, I'm going to subtract x from both sides of this linear equation, and I now have y equals 5 minus x. This is going to come in handy for two reasons, okay, in two spots when we solve this. Number one, now I can actually substitute. What do I mean? If y equals 5 minus x, wherever there's a y, I can substitute 5 minus x for it, okay, and that's what I'm going to do right now. So I have x squared plus, and Mr. Visca always uses parentheses. This was y squared. But for y, we are putting in 5 minus x squared equals 13. All right? So this is the first way this is going to come in really handy. And I will explain the second when we get there. Now we just got to solve this. And I'm seeing x squareds in here. It might be a quadratic, meaning we might have two answers. And wouldn't that make sense? If I have a circle in a line, I can possibly have 2 points where they intersect, which means we're going to have two solutions. Okay, when we graph two things, it's where they intersect. Okay, that's the answer. So let's solve this. This stays x squared. Now, I actually have to, please, for the love of God and everything holy, don't tell me that 5 minus x squared is 5 squared minus x squared. That is a big no-no. Everybody does that all the time. It drives me crazy. That is actually 5 minus x times 5 minus x. I have to FOIL this out. Some people do the box method or the lattice method or tic-tac-toe method. However you want to do it, that's fine. I'm going to kind of do this quickly because we should be good at this. So I'm not going to spend too much time on it. 25 minus 5x minus 5x plus x squared. This expression is going in place for this right here. So we have a positive 25 minus 10x because I'm taking minus 5x and minus 5x. That gives me my minus 10x. Plus x squared equals 13. So let's clean this up. What do I mean? Well, x squared and x squared gives me 2x squareds. I have my minus 10x, and I'm going to do two steps in one here. I need to set my quadratic equal to 0 to solve it. That's the basis behind solving quadratics. Okay? So I'm going to bring my 13 over to the left side. Now it equals 0. What I do to the right side, I have to do to the left. 25 minus 13 is positive 12. Okay, so it's looking good. And I see something else we can do right now. I can divide all of those by 2, leaving me a 1x squared, which is going to make it really easy to factor and solve. So I am going to divide everything by 2. And I get x squared, because these cancel, minus 5x plus 6 equals 0. Now, my children, it's time to booty, cheek, and T-bone. And that's what we're about to do. I'm going to find two numbers that multiply to positive 6 that add to negative 5. If you said negative 3 and negative 2, you would have been right. Those multiply to positive 6, those add to negative 5. And now, I just solve each one of these for zeros. I know to just flip the sign, because anything in parentheses, we just flip the sign, right? If you don't know how I got those, please keep in mind, I have to take each one of these parentheses and set them equal to 0 and solve. Technically, I would just add 3 to both sides and get x equals 3. Okay, I would do the same thing for this parenthesis here, and I would get my two x values. Now, we are not done. We are not done in any way, shape, or form. When I drew the circle earlier, and I said we have a line that goes through it, it intersects twice at 2 coordinates. They don't want just the x values of those coordinates. Each coordinate has an x and a y. Okay? So we only have the x coordinate of each. We need to find the y coordinate of each one. So how do we do that? Well, this is the second time. Okay? This is the second time that this comes into play right here. What do I mean? Well, I know x equals 3 and x equals 2. So how do I find y? Y equals 5 minus x. So y equals 5 minus my x, which is 3. So in this case, y is going to equal 2. So when x is 3, y is 2. And that's one of my answers. And I'm going to do the same thing for my second x value. Y equals 5 minus my x value, 2. So y would equal 3 when x is 2. These are both my answers. And there you go. That is perfect, perfect, perfect. Now, since we may have some time here, let me look how we're doing. We may have time. All right. I would like to show you how to do this graphically. I've got to set these both equal to y. Okay. So I'm going to erase the left side of the board here. Okay, right here. So when we graph things in our calculator, they're y equals. Okay? This one right here, y plus x equals 5, that's real easy to get the y alone. Y equals 5 minus x. But our second equation, x squared plus y squared equals 13, I still need to get that y alone. Meaning, I will subtract x squared from both sides, and I've got y squared equals 13 minus x squared. The y is not alone yet. I need to take the square root of both sides. So y equals the square root of 13 minus x squared. But don't forget, every time we take the square root, I need to put a plus and minus there. So what does that mean in the calculator? I don't have a plus or minus button. So in order to graph my circle, I need to do two lines. Y equals a positive 13 minus x squared. And then on a second line in the calculator, I got to put y equals negative square root of 13 minus x squared. Graphing both of these covers both the positive and negative. Each one of those will graph half the circle for me. And then I would have to graph this, and I use the intersection function. So let's go ahead and do that right now. Okay? That is some old math here. We're going to hit seconds plus 7, 1, 2 to clear this out. I'm going to go to y equals. First, I'm going to put this in. Y equals 5 minus x. Now, if I graph that, that's just a straight line. I go back here. Let me graph. I don't have a plus or minus button anywhere here. So I've got to graph the positive, which is the plus, and the negative. Okay. So I will do square root, bang, of 13 minus x squared. Now, if I graph that, that is just the top half of my circle. It looks like an oval. That's because this is widescreen. The width is bigger than the length. If I made these the same size, and I'll show that to you in a second, it looks more like a circle. Now I'm going to graph this. How come I got to graph 2? Again, we have a plus and minus. So I do the same thing, but it's negative square root of 13 minus x squared. And I graph this, and there's the bottom half. You say that looks more like an I. If I make this more one-to-one, okay, there you go. If I were to continue this, that would look like a circle. So it's going to cross at 2 points. It looks like it might touch once or twice here. So let's zoom in on that area. I'm actually going to zoom. I'm going to do a box because I love the zoom box. And I'm going to create an area where we zoom in and get just this portion of our circle. If I do that, okay, see, it comes over and touches here, then over, then touches here a second time. Second, calc, intersect. Now, which one am I doing? Whatever intersection point I'm closer to, it will give me. And I hit enter 3 times. 2, 3. That was one of our answers. Right here. Let me get rid of this. That was this answer right here, 2, 3. Now let's see if our next intersection is 3, 2. I do the same thing all over. I calc the intersection, which is 5. And now I need to go closer to the other intersection point. And I hit enter 3 times. 3, 2. Look at that. We are good at what we do, people. We are good at what we do. Now, this is the last problem of the notes. And let's get her done. We're going to start out the same way. I'm going to go a little quicker. If you want to pause this and try it on your own, go ahead. If you need to pause it as I'm doing this to catch up with what you're writing or just to re-listen and rewind, you can. I'm going to subtract x from both sides. And I've got y equals 1 minus x. This is critical in my 2 points. 1, I'm going to substitute 1 minus x in for y. And then when I get those 2 x values, I need 2 y values, and I'm going to use this equation a second time. So let me rewrite this. I have x squared. Oh, excuse me. Yeah, I'll be okay. I have x minus 2 squared plus, in for my y, is 1 minus x, but I also have a minus 1 after that. Okay? So this part is what went in for my y. Squared equals 4. Now, I'm going to FOIL this. And if I FOIL this, I get x squared minus 4x plus 4. All right? And before I FOIL the next parentheses, I should notice inside the parentheses, my positive 1 and my negative 1 cancel. So I end up with just negative x squared. If I take a negative x and square it, a negative x times a negative x, I get a positive x squared, and that equals 4. Okay? So let's combine everything that we have and go from there. Oh, I have a 1x squared and a 1x squared. Well, that's 2x squared. I have a minus 4x equals, I want the right side to be 0, so I'm going to subtract 4 from the right side. What I do to the right side, I have to do to the left side, and that goes away as well. So really, all I have here is this 2x squared minus 4x equals 0. I'm going to factor by pulling out the greatest common factor, which is 2x. What's left is x minus 2. And if I booty cheek this and I T-bone it, there are my booty cheeks. Look at that. Oh, look at us. If 2x equals 0, therefore x has to be 0. And if x minus 2 is 0, well, 2 minus 2 is 0. Those are my 2x values. But we are not done. We need a y value for each one of those. So x equals 0, x equals 2, and I know that y equals 1 minus x. So if y equals 1 minus x, y would equal 1 in this case. So when x is 0, y is 1. That's one of my solutions. Same thing here. Y equals 1 minus x, which is 2. So y would equal negative 1. So when x is 2, y is negative 1. And these are my two solutions. It says to check this graphically. I will do that. And I will not do too much of the explanation because we just explained it for last problem. I've got to set both my equations equal to y. Y equals, and I already have my linear one. Y equals 1 minus x. So I need to set this, oh my God, equal to y. Well, let's do that. Okay, so I've got x minus 2 squared plus y minus 1 squared equals 4. My goodness. Let's not, so I mean, we could FOIL everything. We could do that, but let's just keep everything nice and simple. I am going to subtract this whole x minus 2 squared from both sides. Okay, so I've got y minus 1 squared equals 4 minus x minus 2 squared. Okay, now, holy poop, I need to take the square root to get rid of this 2. Wow, I got to square root this whole side. So I have y minus 1 equals plus or minus the square root of 4 minus x minus 2 squared. Crazy. And last but not least, I'm going to add 1 to both sides. So I have y equals 1 plus or minus the square root of 4 minus x minus 2 squared. That's a lot. So I'm going to go to a highlighter. I need to put this into y1. And then don't forget, I can't use green on green. So I'll go, this is going to go into y2 and y3. I need to write this once with a positive in between it and once with a negative in between it. Okay, so that's got to go in 2 times for both halves of my circle. So I'm going to go down here. I'm going to turn this bad boy on. Oh, look at our graph. That's nice. I'm going to clear this. Second plus 7, 1, 2. Go to y equals. My first equation, 1 minus x. Good. My second equation, I'm going to do the plus first. 1 plus this whole monstrosity. 1 plus the square root of 4 minus parenthesis x minus 2 parenthesis squared. Wowzers. And now I'm going to do it again with the minus sign here. No big deal. 1 minus the square root of 4 minus parentheses. Notice that I'm typing this in exactly as it's written. Okay? These are exactly as it's written, my plus and minus. And I'm going to graph this. And it should cross. Okay, okay. Look, it looks like it crosses here. Okay, these 2 points. All right, well, let's check that. I'm going to zoom in closer to here. So I'm going to zoom box. Okay, actually, you know what? You could do that. We can also look in our table where the signs are the same. Okay, this works if we have whole numbers, and we do have whole numbers. You know how to do the intersection. We did that last problem. So I'm going to do that here, okay? I'm going to do that here. So x is 2. Okay, we have an issue. I have an issue here. Okay, what is it? Okay, what is my issue? If I look on my table, okay, if I look on my table, I see that when x, I should probably move up. When x is 0, my y's are the same. That's how I know one of my answers. But look what happens when x is 2. Weird, isn't it? Weird, isn't it? That should be the same. I should have the same y value. So what I'm going to do, I'm going to look at my graph again, and I'm going to zoom in here, okay, at 1, 2, -1, and see what the deal is. So I'm going to hit second, calculate. Actually, let's zoom first. Zoom box. And I'm going to make this box here. And I'm going to put a box around this. And hit enter and start my little box here. Keep on going down and move across. Bam, I'm going to zoom in right there. And there's a straight line. Where are we? Bam. This should be 2, -1. We're getting the 0, the 1, the 0, 1 here. We're getting this point, but we're not getting this intersection for some odd reason. 2 on the x, both my y values should be -1, unless I'm missing this. No, see that? Oh. I'll be okay. How many equations do we have here? We have 3. The first intersection is with the top half of the circle, y2. The second intersection point is with the bottom half, meaning if I look at my table, at 2, here's my line, and that's going to cross not my first half, but my second half. My second half. Ready? So as you see here, my -1 crosses with the second half of the circle, -1. That's tough. That's why I always like to do the intersection. And for a second, I was like, what the heck's going on there? And I go down here, and I enter 3 times. And, ooh, go to. Wow. That is beautiful. Let's go graph. Let's do that again. Second, calculate the intersection. I'm going to go here and hit enter on this line. Hit enter again. Wow, for some reason that has not given us the second intersection point. Good thing we know how to do this algebraically. I'm going to do this one more time for poops and or giggles to make sure I'm not doing anything wrong, which I might be, who knows. Calculate the intersection. Once on this line, the second curve is right here. Now I got to go on the second curve, which I'm on, hit enter, to -1. It's really crazy to use the intersection in the table sometimes when you have 3 curves. But these are things that you got to troubleshoot. And yes, they could be a pain in the butt. All right. See you for Unit 1, Lesson 13. See ya.